Alright, hi guys, how you doing? Welcome back. We're going to go ahead and get started with our warm-up for today. So, your warm-up here, we're going to go ahead and read the question all together first. So, the question says, when an electrical current is passed through a sample of water, hydrogen and oxygen gas is formed. Determine the mass in grams of oxygen required to decompose to form 12 moles of water. Alright, so if we look at this problem, our given number and unit, we have 12 moles of water. Now also, what we are looking for, we're looking to determine the mass in grams of oxygen required. So let's go ahead and look at our equation. So on this equation here, I have not given you a balanced equation. So the first thing we need to do is to balance this equation. Now, we're going to go ahead and balance this one together, and then I'm going to let you work on your own a little bit to go ahead and solve your warm-up. So what we see is, on the right side, we have 2 oxygens, but on the left side, we only have 1 oxygen. So we need to multiply by 2 on the left side. Well, now we have 4 oxygens on this left side, so we need 4 oxygens on the right side. That's going to require us to multiply the 2 here, giving us a total of 4 hydrogens. That leaves us with a 1 for the final coefficient. So go ahead and click pause at this time and take the next 4 minutes to work through your warm-up. Alright, so let's go ahead and come back to our warm-up here. So we know we started with our 12 moles of water. So we're going to go ahead and start with that. We begin with 12 moles of water, which is H2O. So this here is our given. Started with 12 moles of H2O. Now we know that here we're looking for the mass in grams. So this here is a moles to mass problem, meaning that we need to go from moles of X to moles of Y, finally to the mass of Y. So we start out with moles of X here. Moles of X is our 12 moles of water. We multiply this by our first conversion factor, our proportion. Now the coefficients in our reaction tell us that for every 2 moles of H2O, now we need to look at our question mark, what our unknown is. The question is asking for mass in grams of oxygen, so the oxygen here is our unknown. This tells us now that for every 2 moles of water, we have 1 mole of oxygen gas. So after canceling common units, moles of H2O on top and bottom, we're left with moles of oxygen. But we wanted grams of oxygen. So we need another conversion factor that has moles of oxygen on the bottom. So for every 1 mole of oxygen, now we need to look for a total mass of 1 mole of oxygen. Now the mass of 1 mole of oxygen is going to be 2 for 2 oxygen atoms multiplied by the mass of 1 oxygen atom, which is 15.999. Again, after canceling units, moles of oxygen on top and bottom, we now have our final answer in grams of oxygen. So as we do that, let's go ahead and put it all together. On the top here, we have 12 multiplied by 2 times 15.999, giving us approximately 384. 383.976. And on the bottom, we have just 2. So this gives us then a final answer of 191.988. Now we need to look at our significant figures. We started with the number 12, which is 2 significant figures. So our answer should also be in 2 significant figures, giving us 190 grams of oxygen. All right, so let's go ahead and continue on for today. So our agenda for today, we're going to be going through some notes and examples to start off with, followed by some guided practice, and then you will have some time to practice on your own. So today's stoichiometric focus is going to be what we call mass to mole. Now note that this is exactly the opposite of what we did yesterday. Instead of starting with moles of X and going to mass of Y, instead today we are starting with the mass of Y and going to the moles of X. So we're going the complete opposite direction. So go ahead and turn to your examples. The first example you should see, marked example 1 on your handout, should be this problem here. Now, we have an equation also given to us in this problem. So when we start out, let's go ahead and start by reading the problem here. The problem says, how many moles of O2 are required to react with 400 grams of C4H10? So here, our given is 400 grams of C4H10. In our equation, that tells us that this is the given here. Now, we're looking for how many moles of O2. So we go ahead and circle O2. That's our question mark, or what we are solving for. So to start out with this, we've got our 400 grams of C4H10. Now we know that our first conversion factor here, needs to be from grams to moles. We are going from the mass of Y to the moles of Y, and finally to moles of X. So to go from mass of Y to moles of Y, we need to find our molar mass of C4H10. Well, that's going to have 4 carbons at 12.011 plus 10 hydrogens at 1.008, giving us a total mass of 58.124 grams of C4H10. Now we continue by knowing that this was our 1 mole. So 1 mole of C4H10. Now we get to move to our next step. Notice here we still need that next step because while we cancel grams of C4H10, we wanted moles of oxygen. Right now we are at moles of C4H10. So now is our time to use our equation here. So we know that for every 2 moles of C4H10, the equation says that we have 13 moles of oxygen gas, O2. So again, we can cancel moles of C4H10 on top, moles of C4H10 on the bottom, leaving us with our answer in moles of oxygen. So we go ahead and calculate this out. On the top, we have 5,200, and on the bottom, we have 160.248. This gives us our final answer of 44.73. Now again, we need to look at significant figures. We started with 400 grams, which only has one significant figure. So our answer should also have only one significant figure, meaning it should be rounded to 40 moles of oxygen gas. So go ahead and click pause if you still need to look at this. Otherwise, we will go ahead and move on. All right, so here's our second example now. This example here, you are also given a chemical reaction. Wasn't I so nice to you? So here, we're going to go ahead by reading the question first. The question says, how many moles of copper are required to form 163.0 grams of nitrogen monoxide, assuming an excess of nitric acid? So here, what we've been given, 163.0 grams of nitrogen monoxide. We are looking for how many moles of copper are required to form. So if we go ahead and take a look at this problem here, nitrogen monoxide, that's here on the product side. So that was our given. On the other hand, the copper, that's here on our reactant. This is our unknown. Now something here, when it says an excess of nitric acid, all that means is that it doesn't run out. So we're going to go over here and say doesn't run out. So let's go ahead and solve our problem now. So we've started with 163.0 grams of nitrogen monoxide, which is here as NO. Now again, here we're going from mass to moles. So we're going from the mass of Y to moles of Y, finally to moles of X. So we've started with our mass. We now need a conversion factor to go to moles. So this is where we use our molar mass. The molar mass of nitrogen monoxide is going to be equal to 1 times the mass of the nitrogen, 14.007, plus the mass of 1 oxygen, or 15.999. This gives us a total mass of 30.006. So this number then will go on the bottom as 30.006 grams of nitrogen monoxide. On the top then, that is the mass of 1 mole of nitrogen monoxide. What we've done here is converted now from grams, mass of Y, to moles of Y. Now we're still left with moles of nitrogen monoxide, but we're looking for moles of copper. So we need another conversion factor. This conversion factor, we have to use our balanced equation here. So this tells us for every 2 moles of nitrogen monoxide, we have 3 moles of copper. Again, after canceling out, now we are left with moles of copper, exactly what we were looking for. So if we go ahead and solve this through, on the top, we have 489. On the bottom, we have 60.012. Performing the division gives us approximately 8.15. We'll round that a little bit better. We end up with 8.1484 moles. But we started with 4 significant figures. Let's go ahead and write that in. This was 4 significant figures. So our answer should also have 4, meaning we have 8.148 moles of copper. So again, go ahead and pause this. If you need to, look over it. You can also rewind. Otherwise, we're going to go ahead and move on. We're going to go ahead with some guided practice now. So since I'm not there with you, we're going to go ahead. You will see the problem. I'd like you to first take your time, 27 seconds, to read the problem. Write down your given and your unknown. After that, take 78 seconds to solve the problem, either by yourself or with the person sitting next to you, depending on if you're watching this at home or in class. So our first problem here, we're going to go ahead and have you read it on your own. As soon as you're finished reading, go ahead and click pause and try and solve the problem on your own. Once you are done, we'll go ahead and unclick pause. All right, welcome back. So in this problem, our given is 37.2 grams of NH3. We go and circle NH3. This was our given. Now, we are looking for how many moles of water. So we'll go and circle water. That is our unknown. That's our question mark. So here, we're going to start with 37.2 grams of NH3. Now, in order for us to go from mass of this Y, this compound, to our moles, we need to go through another step. We need to first go to moles of Y, followed by moles of X. So here, first, to get from mass to moles, we need to use our molar mass. Here, molar mass of NH3 is going to be equal to 1 times the mass of the nitrogen, 14.007, plus 3 times the mass of a hydrogen, 1.008. This gives us a molar mass of 17.031. So here in our problem, we write 17.031 grams of NH3. Now, since that is a molar mass, this is for 1 mole of NH3. Now, if we go ahead and cancel grams of NH3 on the top, grams of NH3 on the bottom, we now have moles of NH3. But we wanted moles of water. So we need another conversion factor. This one's going to get us from moles to moles, or this step here. So on the bottom, we want our moles of NH3. So for every, in our reaction, 4 moles of NH3, we have 6 moles of water, or H2O. Again, after canceling our units, moles of NH3 on top, moles of NH3 on the bottom, we now will have our correct units of moles of water. So if we go ahead and calculate this out, on the top we have 223.2. On the bottom we have 68.124. This gives us an answer of approximately 3.276. Now we need to check for significant figures. In our problem, we were given 37.2, which has 3 significant figures. So our answer should also have 3 significant figures, meaning that it is actually 3.28. We were looking for moles of water, H2O. So this here would be our answer to the problem. So again, go ahead and click pause if you still need to go through this, or if you need to rewind. Otherwise, we'll go ahead to our second problem. So our second problem here, again, I'm going to have you all read it on your own. Go ahead and click pause and try and solve this problem. All right, so hopefully you've had a chance to try and solve this problem on your own. We're going to go ahead and work it through together now. So in this problem, our given number and unit is 2.41 moles of sodium hydroxide. Well, that's here on our reactant side. This then is our given. The problem is asking for how many grams of sodium sulfate, which is here. So we have, this is our question mark. Now notice this problem. We started with moles. We are looking for grams, or a mass. So this is actually what we did yesterday. We are going from moles of X to moles of Y to the mass of Y. So here we've started with 2.41 moles of sodium hydroxide, which here was NaOH. So we need to set up a conversion factor to get us to moles of Y. That's going to require using our chemical equation. So for every 2 moles of NaOH, we had 1 mole of Na2SO4. So as we cancel out moles of NaOH on the top, moles of NaOH on the bottom, we're left with moles of sodium sulfate. But we wanted grams of sodium sulfate. So now we need to have another conversion factor to get to the mass of sodium sulfate. We're going to go ahead and make our next conversion factor. On the bottom, for every mole of sodium sulfate, now we need our molar mass. So our molar mass is going to be, including 2 sodiums at 22.99 plus sulfur at 32.066 plus 4 oxygens at 15.999. This would then give us a total molar mass of 142.042 grams Na2SO4. So again, after canceling, moles of Na2SO4 on the top, moles of Na2SO4 on the bottom, we're left with grams of Na2SO4. Exactly what we were looking for. So as we multiply everything across the top, on top that gives us 342.32 on the bottom, that gives us just 2. Now, after we divide, we get 171.16 grams. So now we need to look at significant figures. We started with 2.41, which has 3 significant figures. So our answer should also have 3 significant figures, leaving us with 171 grams of Na2SO4. So this here would be our answer to this problem. So again, if you have any questions, please go ahead and pause the video or rewind as you need. Otherwise, we're going to go ahead and move on. So guys, thanks for watching. We're going to go ahead and give you some time now to practice on your own. Go ahead and take some time to practice the mass to mole stoichiometry problems on your handout for the remainder of class.